Hello and welcome to this episode of Packet Tracer. In this episode, we want to have a brief introduction of simulation environment. So let's get started. So by default, we are usually in real-time mode. And in real-time mode, the time is running continuously and it's indicated by this clock. If we switch to the simulation mode, the time stops. And the simulation mode is used to observe network traffic in detail, and time can be directly controlled by us, the user. In the simulation mode, we can stop or slow down time to allow us to view data traffic one packet at a time. Let's add a simple PDU, a ping PDU from PC0, which is the source, to server 0, which is the destination. Now you can see that the packets has started appearing here in the simulation panel. In the simulation panel, we can control time by going forward one step at a time, to continuously play time, and to go backward. These controls are also available in here for us in the simulation toolbar. We also have the ability to hide the simulation panel, so if I click event list, the simulation panel will disappear. And if I click on it once again, the simulation panel will appear once again. The forward button will forward simulation one step at a time. The play button will automatically show and run events. And if we click on the back button can be used to view packets that occurred on a previous time frame. If I click on play once again, the time will stop or pause. If I click on power cycle devices, all of the devices will be restarted and the event list will be cleared. And all the startup processes such as HTTP will initialize once again. And you need to save any configurations before restarting the devices. So if you haven't copied your running config to the startup config, you need to do so, otherwise you will lose your configuration. We can click on no to cancel the power cycle of devices. And that's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to discuss a few features of the simulation panel. So let's get started. First, we want to create a packet from PC0 to server 0. As you can see here in the simulation panel, we have these buttons. The play button will run the time in simulation mode and packets will start forwarding. The forward button will forward the packets one step at a time, and the back button will return to a previous time frame. Now let's play this simulation. This slider controls the speed of the animation and the speed of the time in the simulation mode, and if we drag it to the right side, the time will flow faster, and if we drag it to the left side, the time will be slower. Now let's reset the simulation so you can see the effect of the slider. If I bring it to the left side, the time will be very slow, and you can see that the animation is very slow. Now I'm dragging it to the right side. Now you will see that the animation will be much faster. Now if I click on the play button once again, the simulation time has stopped, and this is the time when the last packet has happened in the simulation. This time is specific to the simulation panel, and it shows the time relative to the last time that the simulation was restarted. And it is very different from the time that's running in here. The last device shows the previous location of the packet, and the at device shows the current location of the packet. As you can see, the packet is currently at PC0, and the type obviously specifies the type of packet. We also have this constant delay. If we have this constant delay enabled, the transmission and propagation delay will be constant. But if we remove it, the transmission and propagation delay will be different. Let me show you how. Let's enable constant delay and let's restart the devices so ARP packets are created. Now you can see that delay between each of the packets are quite constant. It's almost 1 millisecond. And if I remove the constant delay and restart the devices once again, now play the simulation mode, you can see that the time frame between each packet is different. Between these packets it's almost 2 milliseconds, but now see in this packet it's 1 millisecond. And that's how the constant delay make sure that the transmission and propagation delay is constant. The edit filter will allow us to control which events will be visible in the simulation panel. Let's go to the edit filter. We have 4 tabs in the edit filter window: IPv4, IPv6, and miscellaneous. And various protocols are categorized under these tabs: IPv4, IPv6, and miscellaneous. If we add or remove some protocols from the filter, that doesn't mean that these packets will disappear from the network. These packets will still be on the network, but they just won't be visible. So if I remove OSPF, that means that the OSPF packet will still propagate in the network, but it will not be visible to me. Let's go to the Edit ACL filters. Here we can create ACL filters, and let me create a new ACL filter and give it a name. Let's start by permit space IP any. And as you can see, I also have the context help available. Once the carriage return is shown to me, that means that my ACL filter is almost at the end, so I can submit it. And now this statement is added. Now let's close this window and close this window as well. You will be able to see that in the event list filters, I have my all allow filter. Now let's go and delete that filter. Now that filter is gone. We have the ability to show all the filters or exclude all of the filters with this button. Now that I have all of the filters enabled, I can exclude 1 or 2. Or maybe when I don't have any of the filters enabled, then I can include 1 or 2. And that's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to discuss about some advanced features of simulation mode. So let's get started. Here I want to click this arrow and I want to open this area. This area is called the user created packet window. I have the ability to switch between different scenarios. Scenarios allow you to play with a topology with different ways. For example, I have a different packet created on this topology on scenario 0, and then I don't want to lose that and I want to create another scenario. I will call it my test scenario, and then I can create other type of packets on the test scenario, and I will be able to have both of these scenarios available to me at the same time. Now let's go to this window and add some description for scenario 1 or my test scenario. Let's call it test scenario description. Now let's close this window. Now I want to ping PC1 from PC0. Let me write the IP addresses for you so it makes it easier for you to understand. This is 1.1 and this is 192.168.1.2. Let me open PC0 and issue a ping command. Ping 192.168.1.2. Now you can see that the ping packets has appeared here in the event list, even though they have not appeared in the user created packet window. If I forward this simulation a little bit and some ping commands are created, you will be able to see that I can see in real time the result of my ping commands. Let's go a bit further more. As you can see, my ping command was successful. Now let's close this window and see a few other packets. Now as you can see, the quality of service router has created a packet that has a small square mark on top of the packet. This is called the quality of service stamp, and it means that the type of service field is set in the IP header for this packet. We can change the ability to view this type of quality of service marks or to disable this type of quality of service marks here in the preferences. And if I come to show quality of service stamps on packets, if I play with this option, you can see that this mark can appear and disappear. I want it to show all the time, so I will click on show and close preferences. Now let's go and create a complex PDU. I can create a complex PDU by coming to here and add and clicking on the add complex PDU icon. Once I've clicked to the add complex PDU icon, my cursor will change and I can click on the source device and this window will appear for me. Now this is the source device and I can choose the outgoing port, or packet tracer will also auto select that port for me. For my PC, I don't have any other port, so the auto select is good. I have the ability to change between different type of applications, but for me ping is good. I want to enter the destination IP address as well. I can do that by entering the destination IP address using my keyboard, or I can also click here on the destination device and the address will appear for me. The source IP address, I want to leave it blank because the fast Ethernet zeros IP address will be used by default. I can also define the TTL or time to live value for this ping packet. And I can additionally define the type of service field for this IP packet. I need to add a sequence number because this is mandatory, and sequence numbers are used for ping packets or any other packets that have been duplicated, dropped or reordered, and the sequence number is useful for such purposes. The size of packet, I can define the size of packet as well. Well, we forgot to have the sequence number. Let's put 1. The size of the packet, I can define the size of the packet in bytes. Usually it's 32 bytes, but I want to create it 100 byte. We can send this complex PDU at one shot at a specific time. We can specify the time, or we can specify a periodic interval that the PDU will be sent. Remember that this time is related to the time in the event list and it's not related to this time in here. Let's create an interval of 5 seconds and create the PDU. Now as you can see, the PDU has appeared in the user created PDU window. I can toggle this PDU list window and a better view is shown to me. If I double click on the fire field, this PDU will be created and will be sent. The last status will show the status of the PDU packet, if it is in progress or it has failed or it has succeeded. The source obviously shows the source device and the destination shows the destination device. The type shows the type of protocol that we are using, and the color is an indicator of the color here in the workspace. I don't like this color, so I can change it. If I double click on the color, then I can change to another color. Let's select black because I like black. And let's click OK. Now you can see that the color has changed, and it has also changed here in the simulation on the animation, and it has also changed in here in the event list. The time here is the time interval, and the period shows whether this PDU is created for intervals, yes or no. The number shows the sequence of this PDU, and we can edit this PDU once again if I double click on the edit. Or I can delete this PDU altogether by double clicking the delete. Now the PDU is completely deleted. Now I want to toggle back this PDU list window to its place and delete our test scenario. And we go back to our scenario 0, which is the default scenario. And that's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned. Hello and welcome to this episode of Packet Tracer. In this episode, we want to talk about PDU information window. So let's get started. First, I want to go to the simulation mode, and here I am in the simulation mode and I have my simulation panel. Let me create some ping packets from one device to another so that some traffic is generated and my event list is populated. As you can see, my event list is populated and I can see the packets here in the animation and also the packets here in the event list. And if I click on any of them here in the animation, or if I click here on top of the event list packet, this PDU information window will appear for me. In the PDU information window, we usually have 3 tabs, but now for this packet we have 2 tabs, which is the OSI model and the outbound PDU detail. Now let's move forward the simulation so we can have a packet that will have all the 3 tabs. Now in here we have this packet which has the OSI model, the inbound PDU details and the outbound PDU details. Here in the OSI model tab, the PDU information window is showing the information on how this packet is being processed at each layer of packet tracer by the device. You can see that we have some information such as at device, which means that this packet is located here in R3, the source of the device was this router, and the destination of the device was the R3 itself. We have the incoming layers and the outgoing layers. The incoming layers, they show us how this packet is being processed when it's received at this device, and the outgoing layers, it shows us the decisions that this device has taken to forward this message, this packet out of its ports. For incoming layers, we need to start from bottom to and go to the top, and for the outgoing layers, we can start from the top and go to the bottom. If I click on each layer, then additional information about that layer will appear for me in here. Or I can click on this previous layer or next layer buttons. In the inbound PDU information, there is some information about the PDU type and the IP header and fields that is available on this packet when it was received, and the outbound PDU detail is showing the similar information but when this packet is going to be sent out of one of the ports. Now let's go back to the OSI model and let's go to the challenge mode. The challenge mode will challenge you on your understanding of the OSI model and will give you a few questions about each layer of the OSI model. I have been given a question and I have the ability to have a hint. If I click hint, a hint will appear for me in here. If I click the hint again, this window will disappear, and if I hover my mouse over these answers, some hints will appear for me as well. Now let's select an answer and click the next layer so we can process. Our answer was correct, so it went to the next layer. Now I have the same answer, click on next layer and my answer was correct, and that's why I was able to move to layer 3. Now if I click on next layer, my answer is not correct, and that's why I cannot move further. Let me resize this window so that you can see. I'm not sure why this area is not resizing, but it's supposed to tell us that the answer is not correct. Once I've answered all of the questions, I will get this message: congratulations, I have successfully completed this challenge, and that's it. I can close the challenge mode. And that's it for this episode, everyone. I hope this has been informative for you, and I would like to see you in the next episode. Stay tuned.